Be careful now. You have maneuvered Explorer into the vicinity of one of the universe's strangest components. Caution is advised. Space itself may be twisted and deformed in this region. And here's the reason. Theory predicts that if gravity can pack a large enough amount of matter into a small enough space, the universe will invent a black hole. It's black because its gravitational field is so strong that light itself cannot radiate out of it. If you fall in, you can't even cry for help.
At a large distance, they're not a great danger. You wouldn't want to get very close to the black hole, but you wouldn't want to get very close to the sun either. And, for example, if you were at the Earth's distance from a black hole, it would be no different on us than being at this distance from the sun. Except, of course, we don't get any radiation from a black hole to keep us nice and warm.
This idea was first proposed as a curiosity of physics more than 2 centuries ago. It was described mathematically in 1916, and a detailed theory describing how black holes form from certain stars was put forth in 1939. But no one took any of this very seriously until the infant science of radio astronomy turned up 2 quirks of the cosmos. Quasars, enormously energetic objects, now believed to be very young galaxies near the edge of time, and pulsars, ultra-dense spinning stars broadcasting radio beacons across the sky. Suddenly, the real universe began to look a lot like the mathematics had predicted. In the last 4 decades of the millennium, black holes were not only well understood, they were actually photographed. Apparently, they come in at least 2 flavors. Stars bigger than about 10 times the mass of your sun are sure to collapse and keep on shrinking when they run out of nuclear fuel. Nothing can prevent them from squashing down to a point of infinitely tiny size and ultimately huge mass. It's called a singularity, and it singularly warps the space around it, to the point where no information of any kind about what's happening within can ever emerge. The second variety are the so-called supermassive black holes, formed when huge volumes of interstellar dust and gas collect, condense, and collapse by gravity. Every large galaxy seems to have one. Your home galaxy, the Milky Way, has a central black hole at least 2.5 million times the mass of your sun. Its location is well known, lying within the constellation of Sagittarius. It's churning away, accelerating stars to more than 20 times the speed of the fastest rocket before devouring them. Giant elliptical galaxies with plenty of stars and gas near their cores probably have much larger black holes, ranging up to at least several billion solar masses. And growing. On the other end of the size scale, it's also just possible, as physicist Stephen Hawking suggests, that there may be a population of tiny black holes left over from the creation of the universe. What's more, these mini primordial black holes could potentially find one another and combine. Result? Clandestine black holes of all sizes, which could account for some of the missing mass of the universe.
Don't think of black holes as dark matter. They're different.
Black holes can also spin, and most of them probably do. They warp the shape of space around them, producing a phenomenon called frame dragging. Some can even take on an electric charge. A super-advanced civilization might even learn to harness these as a power source for starships. And, weirdest of all, black holes need not be completely black. Professor Hawking has shown how some could be merely spitting out streams of elementary particles. The more you observe the family of black holes, the stranger the members' behavior. Recently, the Hubble Space Telescope snapped a picture of this galaxy. The supermassive black hole at its center appears to be blowing a bubble.